Hi, today we are going to learn how to find the angle bisector of two planes. Now in this question, you are given the equations of two planes, 2x minus y plus 2z plus 3 equals to 0 and 3x minus 2y plus 6z plus 8 equals to 0. And you are asked to find the acute angle bisector of these two planes. Now, we can rewrite the equation of the two planes as such. R dot 2 minus 1, 2 equals to minus 3. And then the other one will be R dot 3 minus 2, 6 equals to 8. Now, these two are the normal of the respective plane. Let's call this N1 and this N2. Now, you are asked to find the acute angle bisector of these two planes. Now, let's say these are the two planes, alright, if you look at it, so one of the plane is cutting it this way and the other plane is going in this way. Alright, there are two angles that when the planes intersect. One is a cube, alright, you have alpha 1 here, and one is, the acute will be alpha 2, the obtuse angle between the two planes will be alpha 1. Now what they want is they want to find the acute angle bisector of these two planes. So this is the plane that they want. Alright, cutting into the paper. So there are two angle bisector. One is a acute and the other one is a obtuse angle bisector. So let's find the normal, alright, that such that the angle between the two planes is acute, alright. So there's two scenarios. It can be of this case or of this case. Now how are we going to find whether the normal or the planes are between the angle between the two planes is acute or obtuse? What you can do is you find the angle between the two normals. Now if the angle between the normal is acute, alright, then the angle between the two planes will be obtuse, because this angle alpha 1 is 180 minus theta. Now if theta is less than 90, if the angle between the two normal is acute, then this angle alpha 1 will be obtuse. Now likewise, if the angle between the two normal is obtuse, then this alpha 2, alright, will be 180 minus theta 2. Now if this is obtuse, then alpha 2 will be acute. Now so let's look at with these two scenarios, alright, with these two normal, whether the angle between the two normal is acute or obtuse. How are we going to do that? We can do that by using a dot product. So we dot the normal. 2 minus 1, 2 dot 3 minus 2, 6. Now this one is very obvious. What do you get? You definitely get a positive because you got 6 plus 2 plus 12. So this is positive. Implies that the angle between the two normal is acute. Now you want the angle between the two normal to be obtuse, because you want the angle between the two planes to be acute. So you must change one of the direction of the normal. Let's take for we can change whichever one, alright, but only one of it. Let's say we change this normal, alright. So this normal will then be pointing in a different direction, this normal will then be minus 2, 1, and minus 2. Whereas this normal is 3, minus 2, 6. Okay? Now, let's find the line of intersection of the two planes. When two planes that are not parallel to each other, they always intersect at a line. Now, how to find the equation of this line? Now, you can key this into your GC or you can find it manually, but keying into a GC is so much easier. So you key into a GC, you will find that this line L1, let me use a different color. This line L will be given 2, 7, 0 plus lambda 2, 6, 1. Now this 2, 6, 1 is a direction vector and 2, 7, 0 is a point on the line. Now let's x, y, z be a point on the plane of the acute angle bisector. Now the normal to the first plane, this will be minus n1. Alright, because we want to make sure the angle is acute, so we will be using this normal. And this angle, this normal will be n2. Now, what is minus n1 will be equals to minus 2, 1, and minus 2. Whereas this will be 3, minus 2, and 6. Now, let this point be 2, 7, 0. Alright, this line here, L, will be pointing into the board here or out into the board, depending on the direction. Now, if XYZ is a point on the plane of bisector, you will find that its perpendicular distance from the first plane will be equals to the perpendicular distance to the second plane. That means this distance here, alright, this one will be D, and this distance here will also be D. Now, how to find D? Let's call this point A and this point C. Now, the distance D will be equals to is the length of projection of AC onto minus N. So it will be AC dot minus N1. Alright, N1 is this. So minus N1, the unit vector. Alright, which also be equals to AC dot unit vector N2. Now, so what is AC? AC is OC minus OA. That will be X minus 2 into Y minus 7 into Z minus 0. I will just leave it as Z. So you dot this unit vector. So that will be X minus 2 into Y minus 7 into Z dot minus 2, 1, minus 2. Now, what is the magnitude of this? This is square of this is 4, 1 plus 4. Then you do a square root, it will be 3. That will be equals to x minus 2, y minus 7 into z dot the unit vector of this unit vector here, n2, 3, minus 2, and 6. But what is the magnitude of this? We need to divide by its magnitude in order to make it a unit vector. This is 9, square of this is 9, 9 plus 4 is 13, 13 plus 36, 13 is 49. So you do a square root is 7. Alright. Then you do a cross multiply of 7 and 3. So you got 7 into, then you do a dot product, minus 2x plus 4 plus y minus 7 minus 2z. That will be equals to 3 into 3x minus 6 minus 2y plus 14 plus 6z. Alright, we can simplify this. That will be 7 minus 2x plus y minus 2z minus 3 equals to 3x minus 2y plus 6z. You get plus 8 here. Okay, so you got minus 14x plus 7y minus 14z minus 21. You multiply this out, you got 9x minus 6y plus 18z plus 24. Alright, this is a minus. Okay, you bring this over, so you got 23x minus 13y plus 4z. Alright, then equals to minus 45. Alright, this is the plane of the acute angle bisector of these two planes. I hope you have learned something from this video. Thank you for watching and have a nice day.